Okay, so I just wanted to address, if you're struggling, a couple more examples of how to graph with the exponential functions that you can use for reference. So first I want to note here, we know it's an exponential function because the x is in the exponent, and our base is 4. So the parent equation that we're thinking about graphing is if we just had 4 to the x. Since the base is 4, and that's bigger than 1, then this is a growth function, which means we expect the curve to go upward as it goes over to the right. Now remember, exponential functions have things they all have in common, but then as the base changes, that changes some of the characteristics. So the thing they all have in common is that they have this asymptote at y equals 0, and they have this point at 0, 1. Then the points around that depend on the base. For example, here, when I plug in 1 as an x value, I would be calculating 4 to the power of 1, which would be 4. So 1 comma 4. When I plug in negative 1 as an exponent, I would be calculating 4 to the power of negative 1. And remember that what a negative exponent does is use the reciprocal, so we would get 1/4. So we would see this exponential graph like so. Now what we want to do is we want to take that and put this on the graph according to the transformations that we see. Now there are two transformations occurring here. One is here in the exponent with the -2, and the other part is the +1. Remember that the transformations that are occurring in the exponent are transformations occurring within the function that you're looking at, and those are your horizontal transformations. So that x minus 2 is going to become a shift right 2. The +1 at the end is a vertical change, and it's going to become a shift up 1. So the only transformations we have in this graph are transformations that involve shifting 2 units right and 1 unit up. So I'm going to take the graph that I see here that I drew as my parent function, and I'm basically going to take each point and shift it 2 units right and 1 unit up in order to draw my new graph. Now remember, shifting left and right won't change our asymptote, but shifting up and down will. So our asymptote is also going to change when we shift up 1. So our asymptote will now be at y equals 1. And then this point that was at 0, 1 is now going to move 2 units to the right, so it's going to be at 2, and it's going to move up 1, so it's going to be at 2, 2. 2, 2. And this point here that was at negative 1, 1/4 is going to move 2 units to the right, so it's going to be at positive 1, and it's going to move 1 unit up, so it's going to be at 1 and 1/4. So positive 1, 1 and 1/4. And then this point up here that was at 1, 4, it's going to move 2 units to the right, so it's going to be at 3. And it's going to move 1 unit up, so it's going to be at 3, 5. And then I can graph my function. Okay. So we see here we accounted for the transformations, we have our asymptote labeled, and we have our graph with our 3 points. And I have one more that I can show you guys if you'd like to see it for reference. All right, so this function, notice that the parent function would be y equals 1/3 to the x, because 1/3 is what they're using as the base. Because 1/3 is the base, this is decay instead of growth, and all that tells me is I expect the parent function to curve like so. Kind of in the opposite direction as we saw with the other. So in this case, again, the things that all exponential functions have, they have an asymptote at y equals 0, and they have a point at 0, 1. Now where those other points are depend on the function. I like to plug in 1. When I plug in 1 as the exponent, 1/3 to the first power is going to be 1/3. And when I plug in negative 1 as the exponent, remember negative 1 causes us to use the reciprocal. The reciprocal of 1/3 is 3. So this is what my exponential decay function looks like from the parent function. Then I'm going to look at the new equation they've given me and all the changes that are taking place. So here what I'm circling in red That is going to be the horizontal changes that I need to account for. And then this stuff I'm circling in green are going to be the vertical changes that I'm going to account for. So horizontally, we are going to shift left 3 because of the x plus 3 and the exponent. Then vertically, first, because of the negative 2 here, we have two things going on. The negative tells me I'm going to have a vertical reflection. The 2 tells me I'm going to have a vertical stretch, specifically by multiplying by 2. And the plus 1 at the end tells me everything is going to shift up 1. So the first thing I'm going to do is I'm going to go ahead and take this whole graph and shift it left 3. So my horizontal asymptote wouldn't change in that case. And every point's going to move to the left 3. So I'm plotting the same points we saw before, but 3 units to the left of where they originally were. So this would be my graph if everything was just moved to the left 3. The next thing I'm going to do is I'm going to do a vertical reflection. Okay? So I'm going to take my graph. Oh, sorry about that, you guys. Erase all of this. I'm going to take my graph and I'm going to reflect it vertically, which means up to down, down to up. So what I'm looking for is now to kind of flip over that axis. So every point's going to get reflected to the other side. So you see this point here is coming here. This point here is going to be down here. My asymptote doesn't move because it's on the axis. And I get the graph now here that's been reflected. Okay. Then I'm going to go ahead and I'm going to stretch it by a factor of 2. So I've done these two. I'm going to stretch by a factor of 2. Now remember, we talked about vertical stretches and compressions moving things towards and away from the asymptote. Okay? So what we're going to do is we're going to take distances that are here and we're going to multiply them by 2. So for example, the current distance of this point right here from the asymptote is 1 unit below the asymptote. Right here is how I'm measuring that, 1 unit below. I'm going to take that 1 unit, I'm going to multiply it by 2, and that's going to now tell me I want that point to be 2 units below the asymptote. So I'm going to move it so that the point appears to be 2 units below the asymptote. Okay? For this point right here, it's 1/3 of a unit below the asymptote. That times 2 is 2/3. So I want to move it so that it is 2/3 of a unit below the asymptote. This point here is 3 units below the asymptote. If I multiply that by 2, I get that I would like it to be 6 units below the asymptote. So it would be down here. Okay? So after my vertical stretch of 2, I can see the difference between the orange graph and the green graph. That's done. So the very last thing I'm going to do, and I'm going to draw the final version of this graph in black on here so that you can see this, is that I'm going to move everything up 1. Now remember, moving up and down changes your vertical, or your horizontal asymptote. So our final asymptote is going to be shifted up 1. So it's going to be here at y equals 1. Okay? And every point is going to move 1 also. So this point right here, okay, was at negative 2/3, and now it's going to be a positive 1/3. This point right here was at negative 2, and now it's going to be at negative 1. And this point right here was at negative 6, and now it's going to be at negative 5. So our final graph should be this black line cutting through here. I'm going to make that darker now so that you guys can see it. All right. So there's the final version of our graph that we're looking at. So hopefully this will help you guys get through those homework problems. And then remember, on Monday we're going to have time to go through this, but it's probably not going to benefit you very much if you haven't tried to do all of these problems on your own. Okay?